And just like we pulled apart the logarithm terms in the last video, we can do the same sorts of things to put them back together if we need to. So maybe I have 2 log x plus log y minus 5 log z. And again, I'm leaving off, whoa, x is not the base. Okay, I'm leaving off the bases here so I don't have to write a bunch of subscripts. Okay, but if this was base 2 or base 9 or base 7, I would have to carry that along in every step. Now our goal is to end up with a single logarithm term, so the log of one single expression involving products and quotients. And if we recall back here on these others, the very last thing we did was take care of the exponents and bring them down as coefficients. When we're putting things back together, that's going to be the first thing we take care of. So any of these coefficients here are going to go back in as exponents. So 2 log of x becomes log of x squared. The y already had a 1 for a coefficient, and the 5 goes back in on the z as z to the 5th. And then some of you will catch on to this faster than others as you're putting them back together, but I recommend if this is new to you to go ahead and just work with 2 terms at a time. So if I have the sum of 2 logs, the sum goes back together as a product. And then in these remaining 2 terms, since they're being subtracted, I know subtraction goes back together as a quotient, as division. So the x squared y goes on the top, and the z to the 5th goes on the bottom. My single logarithm expression that I get from this sum and difference up here looks like log of x squared y over z to the 5th. Maybe I have log of x minus 2 log of y minus 4 log of z. First, I'm going to put the exponents back inside, meaning that 2 log y becomes log of y squared, and that 4 log z becomes log of z to the 4th. Then if I put this difference back together, it becomes a quotient. So log of x over y squared. Okay. Notice in this step the word log only shows up 1 time. It's not the quotient of the logs, it's the log of the quotient. So now I still have a minus sign, which means I'm going to divide these 2 things. I have x over y squared all over z to the 4th. But if you leave it that way on your paper, you're not going to get full credit because complex fractions aren't an okay way to leave things. So some of you will need to come down over here in the margin. Maybe I'll make it a different color. If we have x, my hands will work. We have x over y squared, and we're dividing that by z to the 4th. Z to the 4th is z to the 4th over 1. That means we're multiplying by the reciprocal. And in the end, the x is the only thing on top, and the y squared and z to the 4th are both on the bottom. This is what we're trying to get to. Practice these. Practice putting together plus signs go back together as multiplication. Minus signs go back together as division. If this fraction is not in lowest terms, you would need to reduce it. Again, if it's a complex fraction, you would need to fix it. And And we get to practice in this section going back and forth, spreading things and expanding them out, and then also putting them back together. Some things to keep in mind with our properties is don't cross your wires. Okay, we know that the sum of the logs is the log of the product, or the log of the product is the sum of the logs. But there is no property back here that says what to do, that we can do anything with the log of a sum or difference. If we have the log of x plus 2y, then that's as simplified as it can be. Okay, we can't split that apart in simplest form. Okay, we can't split that apart in any way. Same if there's a minus sign here. We can split apart logs of products, logs of quotients, and logs of expressions to a power. But we can't split apart log of a sum or a difference. Okay, so keep those things straight. Next video, we'll talk about some more properties that we need to understand.